question's asking us for the area under the curve. So we want to integrate from 32 to 64 of this function f of x. So before I write that, to integrate this, we can try integration using substitution. If we let u be the numerator, be log base 2 of x, then we need to also have du if we're going to change the variable of integration. And so the derivative of log base 2 is 1 over x, but then the derivative of natural log is just 1 over x. The derivative of log base 2 of x is 1 over x times natural log 2, natural log of that base. So when you take a derivative of a logarithm function and it's not natural log, you just have to have that extra little piece. So we almost have that. We have the 1 over x part here. We just don't know, we don't have the 1 over natural log 2. So we can write in natural log 2 on the outside. And then this is our du. We have natural log 2. That gives us 1 over natural log 2 on the inside. I'm on a laptop mouse pad tonight. This log base 2 of x is u. And in bottom, we have x. And because I wrote natural log 2 on the outside, we can multiply the denominator by natural log 2. Right? Because those would just cancel out and bring us back to where we started. So the denominator has everything we need for du. It's 1 over, we wouldn't put du in the denominator because it's 1 over x times natural log 2. We have that. That's 1 over x, and then the natural log 2 I just wrote. So using substitution, this is the integral of u du. And so that antiderivative is nice and straightforward. It's just u squared over 2. Oh, and actually, to be correct here, I should scratch this out. The limits of integration change because we changed the variable. And then we're still multiplying by natural log 2. So we got our antiderivative in terms of u. We just need the limits of integration now. So we got to put it back in terms of x before we can put those limits of integration back in, because 32 and 64 were in terms of x. So u was natural log 2 of x. Sorry, common log. Not common log. It was log base 2 of x. Now we can evaluate those limits of integration from 32 to 64. I actually had to stop the video because u was squared, and I forgot that this term should also be squared. Okay, so I actually completed the problem with that mistake, so I've gone back to redo it here. So to finish evaluating those limits of integration, we're multiplying the entire thing by natural log 2. And so log base 2 of 64, that's our upper limit of integration. You raise 2 to the 6th power to make it be 64, right? Yeah, so log base 2 of 64 is 6. But we're supposed to square that result. So 6 squared is 36. So that's the result we get when we plug in 64, and then we subtract it by what happens when we plug in 32. So 32, if you raise 2 to the 5th power, it makes 32. So log base 2 of 32 is 5. And then that gets squared, so it's 25 over 2. And then when you subtract those, it's natural log 2. Then we got 36 minus 25, that makes 11 over 2. So in other words, that's 11 natural log 2 over 2.